Alright, welcome back to Maths with Mr. Hanna. This video we're looking at iteration, which is a way of solving numerically. So we're solving numerically here. So not using algebra, but it's more close to sort of like a bit of a guessing method where you get sort of closer and closer. And that's what sort of iteration is. You're doing something again and again, getting closer and close to the answer. So to show you how this works, I think it's easiest if we just start with an example. So if we've got an equation that's x squared minus 7x plus 1 equals 0. Firstly, I want to rearrange this, and you'll figure out why I'm doing these things at the end of the video. So first I'm going to add 7x to both sides. So on what used to be that side, I'll have a positive 7x equals x squared plus 1. So I've added 7x to both sides and I've sort of flipped it around. Now I'm going to divide both sides by 7. So divide both sides by 7, and I'll get x equals x squared plus 1 divided by 7. Okay, so what I've got is when x equals x squared plus 1 over 7. And so this is kind of the same thing as if we have two simultaneous equations going on, when we've got y equals x and y equals x squared plus 1 over 7. And we're trying to find the point at which those two things intersect. So we're trying to sort of, maybe I'll write over here, we're solving the simultaneous equations of y equals x and y equals x squared plus 1 over 7. And we're sort of solving that system is what we're doing. Another way to think about it is we're going to sort of be finding values of x so that this equation here is actually true. Now the clever thing we can do here, and I'll explain why we're allowed to do this in a moment, is we're going to say this x is kind of like our x out, if you like, our output x, which is often written as xn plus 1, and that's equal to this x here is more like our input x. X input squared plus 1 divided by 7, or using this notation, xn plus 1 is x of n squared plus 1 over 7. So you can think of it as in and out, but more correctly it's written as n and n plus 1. So let's start off with our first value. I just want to we want to guess a value. So I might make any sort of random guess. So let's say that x naught. So this is like x naught is our first guess, if you like. Let's say my first guess is 1. Let's see if 1 is an answer or a root or a solution, you might say. So if we put x0 as xn, so when x is, sorry, let me say that again. If n is 0, then xn plus 1 is x1, because 0 plus 1 is 1. So x1 is, well, xn is 1, so that's 1 squared plus 1 over 7, which equals 1 times 1 is 1, plus 1 is 2 over 7. Now x2 is then going to be, now our xn is x1 this time. So x1 is 2 over 7, we'll square that, plus 1 over 7. And you can calculate that. You can use a calculator if you like, and finding out in decimal approximation is 0.1545. I should note that the decimal approximation for 2/7 is 0.2857. Now we're going to do the same thing for x3. So x3 is our previous result, 0.1545 squared plus 1 divided by 7, and the answer is 0.1463. And you can keep doing that and doing that and doing that until, remember, this is what we're trying to find. So this is when our input of x is equal to the output. So as you keep going, you'll discover that the input is becoming closer to the output. So if we were to do another one, for example, if we were to go to x4, and let's assume I did that, my new answer would be 0.1459. Now you can see that this output is very close to this input here, whereas the difference between input and output was a fair bit before. Now it's getting quite close. So this is very, very close to the answer that we're looking for. And that's what's called the iteration method. So you're putting something, first you have to rearrange so it's x equals something, and then you just pick a random old guess, and then you do the same procedure, inputs and outputs, again and again, until your input resembles your output. And then you're done. So, now I'm going to talk a little bit about why this works, why it's allowed to work, if you like. And the reason's all to do with this idea that what we're creating is two simultaneous equations. So let's plot those two simultaneous equations on a set of axes. Okay, so I'm going to plot these two things on a set of axes, and I've just done that over here. So I've got y equals x. There it is. This straight line here is y equals x, and I've also got this parabola, which is equivalent to x squared plus 1 all divided by 7, and there you go. It takes that parabola there. Now, what's going on here is I've chosen a random guess. So let's say in this case I chose the random guess of 1. So if I put 1 in, and here just allow me to zoom in a little bit. Here we are, zoomed in. Okay, so the initial guess was 1. So when you put 1 in, you get this as the output here. Now, this output value is going to become the input. An easy way to see this graphically is because this line here is actually y equals x, as you remember from before. So to map this output onto the input, you can go directly horizontally across until we hit that straight line of y equals x, and then go either up or down until we hit back to our equation. So this is, so let's do this properly. So 1 was our x naught, so our x naught there. And whatever this value is here across on the y-axis is this point here. So that's sort of our x1 is whatever value that is there, our x1. So then from there we'll repeat, go directly horizontally across, and then down again. So this value here is our x2 value right there. And then repeat that process again, and it'll be very, very similar. x3 is that value there. So you can see that as we repeat this process, we get closer and closer and closer to this value here. And that is going to be the value that if we had just plotted this thing here, this initial equation here, whoops, that's where that would cross the, that is where that would cross the y-axis. So there we go. There's solving numerically. Now, some of you are probably wondering, quite cleverly, what's the deal, or let's think again. Here, this is a quadratic, so it might have one solution, or it might have two solutions, or it might have 0 solutions. Okay, so there are some cases in which this iteration method will not actually work, and that's when there are 0 solutions. There are some cases when this will work and give you one solution, and that's the only solution. And there are some cases where there are actually 2 solutions. So we've only found one solution, but there are actually 2 solutions to this equation. Maybe I'll plot it for you now just to prove that that is true. Let's just hide these. Okay, so our equation was x squared minus 7x, 7 times x, plus 1. Well, might need to zoom on out, I think. Okay, here we are zoomed out. So there are in fact 2 solutions, and you can see that one of them is the one we've already found here, which is going to be quite close to 0. And the other one here is going to be almost 7, but not quite. So let's go back and investigate for ourselves. Okay, so we found one solution, but not the other, and we're kind of thinking about why that is. And that is because we started our first guess here at 1. So we went here, then across, then down, and then sort of across and down, and found our answer there. But what if we had have started somewhere else? So consider if we had have started our first guess at, say 5. 5, we would have guessed there, then we would have gone across to there, then we would have gone down, across, down, and then we would have got the guess that we had before. What about 6? 6 would have been very similar. That would have been up and down, and then a similar thing would have happened, and we would have got down there again. But what about if we had have started at, say, 9? And this is going to, well, let's start at 8 instead. How about that? So at 8, go up. So that's the wrong direction. We go up to 8, hit there to go this way to the line, and then it would go up and off the page, and it would just keep going up and away from this point. Or if we started at 7, which is quite close to the answer, hits there, but then it goes across, then goes up, and then across, and then up, and then away. Once again, that just goes away from the answer. So this route here cannot actually be found using this method, which is very, very interesting, I think. There are fairly cleverly written mathematical bounds or parameters, if you like, different methods for finding whether or not a particular iteration or iterative equation, such as this iterative equation here, there are methods for finding out whether or not this will or won't converge to a particular point, but that is well outside of this course. So even though this particular iterative equation does not converge to this particular point here, there are other sort of clever things we can do that will allow us to find that point. And that clever thing is arranging this initial equation that we had, x squared minus 7x plus 1 equals 0, arranging that in a new way to create a new iterative equation. So let's do that now. So I'm going to start by adding 7x to both sides and taking away 1. So it'll be x squared equals 7x minus 1. And now I'll take the square root of both sides. So technically it should be plus or minus square root of 7x minus 1. And this gives us our second alternative, x n plus 1 equals square root x n minus 1. So here's a new iterative equation, different from this one over here. A new one we can use to try and solve to find the which will actually find the other point. So I'll show you that it does find the other point. Here I've graphed the two things. So here once again the straight line is y equals x, and this second one is what we had before, y equals plus or minus the square root of 7x minus 1, as we had before. That's this graph here. So now we can take a guess, and maybe we'll go with 10, why not? So this time we go up to here, and that's our x0 at 10. And then we'll go across here and down to our graph again, so that'll be our x1, then across and down, x2, across and down again, x3, and roughly there, that's our x4. So you can see it's probably going to take us about 4 iterations to get a reasonably accurate, 4 or 5, a reasonably accurate value for x. So we can actually do it if we want to. So that time I started from an x0 of 10, I did graphically. So we can do that. So our x1. So let's only use the positive roots because we know that it's going to be in the positive region because of the graphs I have drawn. So this would be root 7 times 10 minus 1. And that turns out to be, which comes to, well, square root of 69, which is, let's just grab our calculator because I don't know what the square root of 69 is. Shame on me, I know. Square root of 69. Oh, thanks for that calculator. Is 8, let's just say 8.3 for now. Roughly 8.3 ... because I know there's more going on. Now to find our second value, x2, put this value into it. So I'm going to 7 times, now I'll write the exact value because I don't want to write something inexact in there, minus 1 will get us the next value. So at this point I'm going to show you how to just do this using the CAS calculator. So let's whip it out. Okay, so our first guess was 10. So first guess was 10, so we'll just go 10, enter. Now what we did to get x1 is we took the square root of 7 multiplied, instead of writing 10, I'm going to say our answer, control answer, was 7 times our previous answer minus 1. And there we go, it's 69. Now, if I press enter again, what it will do is take root 69 and put that in for where I said answer before. So here it's got 7 times our previous answer, this one here, minus 1. And so I can just press the enter again and again, and our CAS will do the iteration for us. Now you can see that these values are unhelpful for seeing whether or not this value is close to this value or not. So to fix that up, we need to put our calculator into approximation mode. So let's go in home and then down to settings, number 5 for settings, document settings, now we need to go into calculation mode, and we're going into approximate mode. Okay, so now let's try that all again. We'll grab a new calculator page. Okay, we'll try it all again, now in approximation mode. So 10 is our first guess, then we had 7 multiplied by our answer, minus 1. There we go. There's our approximation, and that was indeed what we had before, 8.3 something something something. And now our next one, there we go, 7.55, and our next one, and next one. And you can see each time I'm getting the input and output are getting closer and closer to each other. So if I keep going, I'm just going to go for a whole bunch of them. There we go. Now they're getting extremely close to each other. You can see that they're, well, here and here, they're identical to each other to that many decimal places. So you can also count along how many x values you've got. That's 1, 2, so x0, x1, x2, x3, x4, x5, and so on and so forth. And I could list there if I wanted to. So there you go. There's a brief introduction to iteration.